due to the relative position. So if kinetic energy is the energy due to the motion, the potential energy is the energy due to the relative position, between particles. This is the definition. Due to the relative position between particles. There is no, so because it's the relative position between particles, always what is meaning, or what we have meaning, is in the change in potential energy. Delta U. U symbolize the potential energy. What will be by definition delta U, or the change in potential energy, will be equal to the work done by the external force to move the object at constant velocity. So the work done by the constant force to move the object at constant velocity. This is the definition of change in potential energy mathematically. This is just a definition, general definition. Energy due to the relative position between two particles. And delta U is equals, if you want to calculate, you need to find the work done by the external force done at constant velocity, when you are moving the object at constant velocity. This is the way to find mathematically. Now, this point is very important to introduce the definition of conservative force and non-conservative force. Conservative force and non-conservative force. Why it is important to introduce this term? Because delta U always will be associated with the conservative force. So we never will find the change in potential energy for a non-conservative force. So the delta U always will be related to a conservative force. So if the force is non-conservative, there is no change in potential energy for that force. So, well,
is that the same U from like chemistry, like internal energy kind of?
Yeah. Except that U that you use in chemistry for internal energy, in chemistry, is the summation of all energy.
So like the system and
The internal energy, what you use in chemistry for you, is the energy of the whole system, including kinetic energy, potential energy, right? All type of energy that has the system, or the gas, or whatever, they label U. For the molecules, they label the kinetic energy and potential energy, that internal energy. Okay? But here is just the potential energy, right? Because kinetic energy we will label with K, and potential energy we will label with U. Now the total energy, mechanical, which is the kinetic plus the potential, will be mechanical. We will learn today that. Okay, thank you. So the addition of both will be the total mechanical energy for us. Then for them, they can have also, potential energy, kinetic energy. That summation is what they call internal energy. It's just the kinetic energy and the potential energy. So, and they label you. Okay. Now, delta U is associated with the conservative force. What is a conservative force? Conservative force will be that force that the work done by that force, will depend only, this is dependent symbol, only on the initial and final position, not on the path taken. On the initial and final position. Let's say if we use R, will be Ri and R finally. We use X initial and X final. So on the initial and final position, not on the path taken. on D. So doesn't depend on the, not on the path taken. Depends only on the initial and final position, not on the path taken. So in other words, let's say if this is point A and this is point B and this is my initial position and this is my final position with respect to any coordinate, let's say with respect to this coordinate system, this is my point A and this is my point B. So the work done by that force that is moving the object from here to here, let's say that this is the force. The force that is moving from here to here, the work done by that force only will depend on the initial. In the formula, you will see that only will depend on xi or ri and r final, but not on the path taken. In other words, will depend on the displacement, but not on the distance. This will be a conservative force. So it doesn't matter how you go in order to move this object from here to here. It doesn't matter the way you go. You can go this way, you can go this way, you can go this way, you can go this way. In the way you go, the work will be the same. Because only depends on the initial and final position, not on the path taken. Now, that will be if the force doing that work and the work only depends on this and this, that force will be conservative. Let's say for instance, if I go from here in any way and I come back to here, what will be the work? 0. Because only depends on the initial and final position. If the initial and final position is the same, the work has to be 0. So, the work done by a conservative force, as a special case, we can say that the work done by the conservative force will be 0 if the force is conservative on a closed path. On a closed path. So, the work done by a conservative force will be 0 on a closed path, always. What will be a non-conservative force? So, if this is a conservative force, what will be the definition of non-conservative force? Depends on the path taken. A force that depends, the work that done by a force that depends on the path taken, on the distance, will be a non-conservative. Why it is important and why I am introducing this term again? Because every time that you have a conservative force, there will be a potential energy associated with that force. But if it's a non-conservative force, there is no potential energy related to that force. Now, let me just give an example. Let's say that we have this system here, and I bring this from here to here. How much work I will exert to go from here